We're going to review our test 1 solutions and questions in preparation for our exams. So question 1 reads as follows. The dataset shows the daily demand for hammers at a hardware store over the past 20 days. So we have the daily demand shown in this box. To start with, this is called ungrouped data because it's not classified, it's not grouped in classes. And for 5 marks, we've been asked to develop what is called a frequency distribution table that summarizes the data that is showing in here. And number 2, we've been asked to develop a relative frequency distribution table. And finally, to draw or develop a cumulative relative frequency table. So there are 3 things that we've been asked to do here. Number 1, just the frequency distribution table. Number 2, the relative frequency table, and cumulative. We can do all this in one table. So our daily demand starts with the lowest figure, which is 0. So how many zeros do we have here? We can do them by cancelling them out. 1, 2, 3,
There are 4.
4. So the demand of 0 stands at what? At 4, as shown in the table here. That's a frequency. Then the ones, how many do we have? 1, 2. So we have 2 for the ones. The threes, how many do we have for the threes? Oh, the twos before we go to the threes. The twos, we have 1,
4.
2, 3, 4, 5, 5,
I think there are 5.
6, 7. So the twos are 7. Then we go to the threes. How many are they? 1, 2, 3, 4.
4.
And finally the fours. 1, 2,
3.
3. The total here must add up to 20. Are we together so far?
Yes.
Read
Put
it
together.
out of the total. So the relative frequency will be 4 out of 20. This is 0.2. 2 out of 20, 0.1. 7 out of 20, 0.35. 4 out of 20, 0.2, and 3 out of 20, 0.15. Can you confirm that randomly? That is how we find the relative frequency. To go to the cumulative relative frequency, we add on. The 0.2 comes here, and 0.2 plus 0.1 is 0.3. 0.3 plus 0.35 is 0.65. 0.65 plus 0.2 is 0.85, and 0.85 plus 0.15 is 1. The end result of the cumulative frequency must be 1. All right. Then we could also come up with what we call the relative frequency, the cumulative relative frequency. We could have added a cumulative frequency graph along here, where we start with 4. Then we add 2, we get 6. Then we add to 7, we get 12. 6 plus 7, what do we get? We start with a 4, we add 2, get 6, 6, we add to get
13.
13. 13, we add a 4 to get what?
17.
17. And to the 17, we add a 3 to get what?
20.
20. So the relative is 4 out of 20 as a first figure, 6 out of 20 as a second figure, 13 out of 20 as a third figure, 17 out of 20, then finally 20 out of 20. This is how we get the cumulative relative frequency. Cumulative relative frequency. At this point, any questions before I go ahead? At this point, any questions before I go ahead?
None on my end.
Are we all clear? Anyone behind so far? Before I proceed, anyone behind so far? I don't want to leave anyone behind. Please ask.
I joined the class late, so I don't know if I should ask or not.
Now, from what I've taught so far, we're just looking at how to construct a 3-in-1, a frequency distribution table, a relative frequency, and a cumulative relative frequency table. So we have just constructed one. Those that have joined late will not repeat it. I just want those ones for now that I've just gotten it. Okay. Then we go to a second question. We're given data which is grouped like this, and we'll be asked to calculate the weighted mean among others. So computer standard deviation and the variance. So the data is already grouped. We have 20 to 24, 25 to 29, 30 to 34, 35 to 39. Already this data here can suggest one thing. The height is 5 because we can get the height, the distance from one bound, either the lower or upper bound. So 20 to 25, 25 to 35 to 30, 30 to 35. So our height here is what? Our height here is 5. Then the number of employees would stand for the frequency. So we have 8, 37, 25, 48, 27, and 10. This frequency has been given. Using this frequency, we can come up with what is called the cumulative frequency. So we start with the 8 here. 8 plus 37, 45. 45 plus 25, we have 70. 70 plus 48, we have 118. 118 plus 27, we have 145. And 145 plus 10, we get 155. This is what we call the cumulative frequency. For the midpoint, you just find the first one, 20 plus 24 equals, then you divide by 2. You give you 44 divided by 2, which is 22. Then keep adding a 5 because this is a height. So 22 plus 5, 27. 27 plus 5, 32. 32 plus 5, 37, until you reach the last figure. This is a shortcut of finding the midpoints. Otherwise, you can continue adding 25 plus 29, then equals, you divide by 2, you still get 27. 34 plus 30 divided by 2, you still get 32. So this is how we get the midpoints. So we only need 3 totals. The totals that are relevant only have an F. The total for this column should be the same as the cumulative frequency last number. So this should be 155. This is summation of F. Then F times X is called Fx. Multiply 8 times 22, we get this. 37 plus 27, we get this figure. 25 times 32, we get this until the last 10 times 47, we get 470. The total is called the summation of F. Summation of Fx. So the summation of Fx is 5357. To get the Fx squared, don't square this. You simply start from the F and you multiply it to the X squared. So the X squared column is simply, when we square this, 22 squared times 8, we get 3872. 27 squared times 37, we get 26,973. 32 squared times 25 until the last number, 47 squared times 10, you get 22,090. The total of this column is called our Fx squared. So you discover that only these figures that have F's are relevant. Now before I scroll down, can an intelligent student remind me, how do we calculate the mean? What is the formula for the mean? What is the summation for what is the formula for the mean for group data? Betha, how do you find X bar?
Sum of x squared over n.
Sum of
X squared over n.
no, for the
Submission.
it's summation of Fx over summation of F. That is how we find the mean for group data, summation of F over summation of F. So 53, 55 over 155. So the answer we get is 34.54. This is what we call the weighted mean. Okay. Then how do we find the variance? How do we find the standard deviation? So the standard deviation is the square root of the variance, and the variance is summation of f x to the power 2, summation of f all squared to the power ef, everything over ef minus 1. So we had efx to the power 2, 19, 18, 75, then summation of f 53, 56, then summation of f 155, everything over 155 minus 1. So between you and your calculator, when you compute it, the answer you find inside is your variance, and when you square root it, it takes you direct to the what? Our standard deviation. So this is 6.678. When you square this answer, it becomes what we call our sample variance. Our sample variance has this symbol. Our population variance has this symbol. Our sample standard deviation has this symbol. Our population standard deviation has this symbol. Although lecturers were negligent to you using either of the formulas, but to be specific, a sample with listed figures that are there is supposed to be denoted by these letters S and S squared. So squaring this 6.6 gives us 44.59. That is what we call our sample variance. That is what we call our sample variance. So we are reviewing test 1. Question 1 has been done. Question number 2. Describe the 5-number summary for a box whisker plot. And the following data shows the number of days it takes for an author to write each chapter of the 15-chapter book. So these are the number of days. So this number of days have been put in this box, and we've been asked to construct a box whisker plot for the data and describe the shape of the distribution. Okay, to start with, we need to describe the 5-number summary for what we call a box whisker plot. So the 5-number summary for a box whisker plot are: number 1, it should have a minimum, it should have a maximum value. So we have our minimum, which is at A. This is called our minimum. Our B is our maximum. Our C is our first quartile. Our D is our third quartile. Then we have our median here as our A. So this is a minimum, that is a maximum. This is a lower quartile, which is Q1. And this is the upper quartile, which is Q3. And this is our median, which is Q2. And this is our lower limit, or minimum L, and the upper limit U. But now, going by this, we can first rearrange the data in ascending order. We have 9, we have 13, 13. It's already in ascending order, so it has been enlisted for you as follows. Now, with this data set that has been given, we need to first find our C, which is our lower quartile. Our lower quartile is a quarter of n plus 1. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So a quarter of 15 plus 1, which is 16. A quarter of 16 is 4. So a quarter of 16 is 4. We're going to look at the 4th data set. So when we count 1, 2, 3, 4, this is our Q1, which is 13. We put our 13 here. Our upper quartile, so the quartiles. First quartile, the first quarter is Q1. The second quarter is the median or half, which is Q2. The third quarter is the upper quarter, or the 75th quartile. It's 3 quarters, 75% is Q3. So 3 over 4. Except for on group data, we do multiply this one by n plus 1. So a quarter of 16 is 4. So digit number 4, 1, 2, 3, 4. We put 13 on the first quartile. Our second quartile is half. Half of 16 is what? 8. So our Q2 is 8. Half of 16 is 8. So 1, 2, 3, 4, 5, 6, 7, 8. So 15. So this is 15 here.
Mr. Collins, isn't the total number 15 observations, not 16?
It's 15. But like I mentioned, the quartiles, we are multiplying them by n plus 1, not by n. So 15 plus 1 goes to 16. So that's why 16 is.
Got it.
So half of 16
Thank you.
is 8. 8 number is 15. So this is where the 15 is coming from. And 3/4 of 16 is 12. So we go, this is 8, 9, 10, 11, 12. So 26 here. So we put our 26 there. So this is our third quartile. All right. The lowest number we had was what? 9. The lowest number, the minimum. So here we put our 9 there. The upper is 49. The highest number, the maximum is 49. The interquartile range is the difference between the upper quartile and the lower quartile. The difference between these two. 26 minus 13. So the IQR, which is called the interquartile range, is actually the difference between these two. So it's 13. So that is how we get the interquartile range. 26 minus 13 is 13. At this point, any questions? Okay, so now we proceed. So our minimum value is 9. Our maximum value is 49. The lower quartile is 13, and the upper quartile is 26. So this is how the spread looks like. So the comment is that since the data is spreading towards the right of the median, hence it is skewed to the right. The shape of the distribution is right skewed. So here we have our lower quartile, which is 13. Then here we have our median, which is 15. You see, this difference is 2. There's a bigger gap here from 15 to 26, so it's skewed to the right. From the distribution, you're able to tell that there's a bigger chunk between here and the upper quartile. So if here we have 4 measures, and this side we have 4 measures, it is normally distributed. What I mean is that the distance from here to here is 4, and from here to here is 4. It's a normal distribution. But where we have a distance from here, from the lower quartile to the median, maybe 2 here, and from the median to the upper quartile, 6. We can say this one is skewed to the right. There's a more gap this side. If the opposite was happening, if we have a gap from here, 6, and from here is 2, we would say it's skewed to the left. We can tell this even using what we call the whisker plot. So this is how we can define the distribution using the whisker plot. So in simple language, you can draw the whisker plot like I advised. The smallest value, the minimum was what? Who remembers the minimum was what?
9,
Maximum,
49,
the lower quartile, 13,
13,
the upper quartile,
26,
36, and the interquartile range, IQR,
13,
13,
13,
and the median, median was what? 15. So the distance from here to here is what? 2. The distance from here to here is what? 11. So what is our comment? Is it skewed to the left or to the right?
To the right.
To the right. Good, because the gap is bigger here. So 1.5 IQR is what we call a correction term. 1.5 times IQR is called a correction term. So what is our interquartile range?
13,
So 13 times 1.5,
19.5,
19.5. Now listen to me carefully. If we multiply 1.5 to the interquartile range, we get what we call a correction term, 19.5. So this 19.5, we subtract it from the lower quartile and we add it to the upper quartile. So let's first subtract 13 minus 19.5. What are we getting? I repeat, 1.5 times IQR gives you what we call a correction term, 19.5. Then we subtract the correction term from the 13 and we add the correction term to the upper quartile. And the figures that will lie outside this range are called outliers. So what is 13 minus 19.5? Negative what?
0.5.
negative 6.5,
5.
Negative 6.5. Then the upper limit, we add the 19.5 to the 26. What are we getting?
45.5,
45.5. So now, when we go to our range, which numbers are outside these limits are called outliers. The numbers that are outside this range, our lowest number was what? 9. Our highest number was what?
49.
Already 49 is outside this range, right? It's an outlier. Which other numbers are not captured in here? Let's go to our range. Which numbers besides 49? It's only 49, right? Yes, it's only 49. Our range was only going from what? 9, from negative 6 to 45.5. So the outlier is what? The number that is not captured within the range. The number that is not captured within the range. That is what is called an outlier. At this point, are there any questions before I proceed?
Mr. Collins, so the numbers that are not captured, why can't we add the others that are not there? Is it just one of them that's not captured, like 49?
Yes, it's only one. So if we had from this range, if we also had 36 and 39 and 49, 46 and 49, they're all outside the 45.5 because this one's already captured in the 45.
Yes. Yeah.
So if we had 46 here, it will be part of it.
Oh, okay. All right. Got it. Thanks.
Any other questions? Any other questions?
How did we get the -6 on the other side?
How did we get the -6 on the other side? Somebody can answer that. How do we get this -6?
So the -6.5 is obtained from subtracting the correctional form from the lower quartile.
So this 19.5, we subtracted from 13 to get -6.5. This 19.5, we added to 26 to get 45.5. Any numbers outside this range are called our outliers.
Okay.
Any other questions? Okay, so we'll end here for tonight. So we'll continue the other 2 questions remaining in the test. You meditate on what has been discussed for now. All the best, unless there are any other burning questions.